factor 12c squared plus 39cd minus 36d squared. Now, some people might be inclined to jump straight in with the AC method because they see this as a trinomial with a leading coefficient other than 1. But if we multiply a times c, 12 times negative 36 is negative 432. So we would be looking for two numbers that multiply to negative 432 and add up to 39, which is doable, but a little bit ridiculous. And there's a much easier way. We first notice that there's a GCF of 3 that we can pull out of each of the terms in this polynomial. And we know that we should always start with the GCF, so let's pull out that 3. When we pull out the 3, that leaves us with 4c squared plus 13cd minus 12d squared. Now, inside the parentheses, if we look at the leftovers, we will still need to use the AC method there because we've got a trinomial and there's a leading coefficient other than 1. But after pulling out that greatest common factor, things get easier. In this problem now, AC is going to be negative 48 because A is 4 and C is negative 12, and 4 times negative 12 is negative 48. And B is going to be 13. So we need two numbers that have a product of negative 48 and a sum of 13. And it might take you a little bit of time to come up with those numbers, but I will give them to you. They are 16 and negative 3. 16 times negative 3 does give us negative 48, and 16 plus negative 3 gives us 13. So we're going to use those numbers to split the middle term, but I'm going to do a couple of things first. First, we need that GCF3 to stay out front. And when we use grouping, we're going to end up introducing some parentheses into the problem. So to make things a little bit more clear, I'm going to change these initial parentheses to brackets. You'll see in just a moment how this should make things a little bit clearer. Now, we're using the AC method, so we need to split that middle term. So the 4c squared is going to stay there, but then the 13cd is going to turn into a 16cd minus 3cd, and then we also have that negative 12d squared at the end. Now that there are 4 terms inside the brackets, we can factor that by grouping. So let's look at each of those groups separately. I'm going to keep that GCF of 3 out front. It's always going to stay there out of the way. Now let's look at the first group. If you look at the first group, both of those terms contain a 4c. So I'm going to pull out 4c, and then the leftovers are going to be c plus 4d. Now if we look to the second group, both of those terms have a negative 3d in it. So I'm going to pull out negative 3d, and that's going to leave us with a positive c and then plus 4d. Good. So now we still have that 3 out front, but let's continue with our grouping. Each of those groups contained a factor of c plus 4d. So I'm going to have that be the GCF of the groups. We've got our c plus 4d out front. And then if we get rid of that, the leftovers from grouping are going to be 4c and negative 3d. So when we finish off grouping, we've got c plus 4d and 4c minus 3d. We also have that 3 out front. And there's one more thing we can do just to clean this up a little bit. At this point, everything is being multiplied. We've got the 3, and that's being multiplied by the c plus 4d, which is being multiplied by 4c minus 3d. These brackets are not actually necessary. We can get rid of them, and it doesn't change the meaning of the expression. It's still 3 times c plus 4d times 4c minus 3d. And it just looks a little bit nicer when we don't have any extra grouping symbols that aren't necessary. So our final answer is going to be 3 times c plus 4d times 4c minus 3d.